we continue the class. Okay, so this is the example. For the frame, I show this figure. Draw the free body diagrams of the. We also have three parts. The A part is draw the entire form, including the pulleys and the coils. Okay, pulley and coils. And the B part is the form without the pulleys and the coils. And the C part just each pulleys. Okay, so I think the entire form is very easy to do because we don't care about the internal force of each part. Okay, so just use okay, we have the pin support at here, and we have the say the cable support that at here. We have the one force at here, and this entire form we can see like one object. So in the support pin we have the two direction reactions, and in cable support we have the tension force, reaction force, and we have the one force 500 Newton at here. Okay, so the A part is very easy to draw, and the B part we need to draw this object and two without a pulley, but see how we need to draw the pulley. Okay, so in this part we can draw the reaction first. Okay, so we have this part and the reaction at here. So we also have this reaction. And okay, this is the force. Use the cord. So we have the force at this direction, internal force. And the pulley or the pulleys use the pin to connect with this object. So this is a pin and this is a pin. So we have the two direction force, BY-BX and the CY-CX. And when we draw the free body diagram about the pulleys, we also have these two forces at the pin, okay, and at the pulley center. And this pulley, the big pulley, we have connect the cord. So we have the two force because this is connect point and this is connect point. So we have the two force. Here the force is equal to 500 Newton. And in small pulley, we also have the internal force C and CY, and we also have a tensile force, reaction force at here. Okay. So we can draw a free body diagram for each part of this object, this pulley. When we combine these three parts, then the internal force will disappear, and so just show the external force like this. This next example, draw the free body diagram of the members of the black hole shown in this photo. And the black hole and the content have the weight W. So this content, okay, we have the weight. And I think we can see this black hole have so many members. Okay, that's this part, like this part, like this part, and like this part. And also have this part and the bucket and content. Okay, so we have so many parts to need to draw. Okay, so like this part, we have the pin connected here. So we have the force in this direction because this is a two force member. Okay, so we have the HI And at point F, we also have a pin connect. So we have a two direction force. And at point B, okay, EB is the two force member. So we have the force along this direction. And C also CB, the member CB also same concept. So we have the BC here, and point T we have a pin connect and connect this object. So we have a two direction force. And about the bucket and content, we have this pin connected at the point D. So this is the internal force. And we also have the force at the AB member. Okay, because AB member is also is two force member. So the force just along the AB direction, and we have the external force, just the weight. Okay. And point C, okay, you can see the point C also have the internal force, and the FB we have the three internal force. Okay, because come from the three members. Okay, then when we combine this 1, 2, 3, 4, combine together, just only okay, we don't care the internal force, just use the external force. So okay, just only IH, okay, FHI, and this F, at point F, we have a pin connected, so we have a two direction force and the weight. Okay, next example, draw the free body diagram of each part of the smooth piston and the link machine. Machine is to crash recycle cones. Okay, that's this figure. So we have a 1 and 2 and 3. We have a 3 member and one support here, and this is the pin support, and we put the force here. So we have a 3 object, 3 member. Okay, so first member is the A and B. The A and B is the two force member. So the force just along this direction. Okay, so we have the FAB from this to this and FAB from this to this. Okay, and I think this member is very easy because we have the connect pin at the central. So we have the two internal force in this direction and this direction. And when you put the this member to this part and this part, we have the reactions. Okay, so we have the NW reaction and the P reaction. Okay, and on this member, okay, we put a force here, so put a force here, and point B use pin connect, but okay, B just connect at the point B, and AB is a two force member, so the internal force like this, use the FAB, and point D use the pin connect with this member. So we have the two direction force, and this two is internal force. Okay, so when you combine these three member, combine together, you just get the external force, no internal force. Okay, next example, determine the tension in the cables and also the force P required to support the 600 Newton force using the frictionless pulley system shown in this figure. So we have the 1, 2, 3. We have a 3 pulley, and we have the, I think, okay, from A to B, okay, to C to P. We have the one cables. Okay, we have the one cables. So we have a tension force P on this cable. Everywhere on this cable is the same tension force. Okay, and we have connect pin at this point, and at this point. Okay, and we have the support at here, just like the cable support. Okay, so in big pulley, we have the external force P, like this to this, because same, we use the one cable, so the tensile is same, and we have the internal force on the pulley central. So we have the this reaction force and this tensile force. And in middle pulley, we also like this part, but you can see only the connect force, this member. We only have this direction tensile force, and these two tensile force is come from the cable, so only one cable, so only one tensile force. And the middle pulley, middle size pulley, we also use the same concept. Also, so the cable's tensile force is same. In the central, we have the weight. Okay, we have the force here, and we have the we use the cable connect with this pulley. So we have the tensile force at this pulley. And we need to determine the P, okay, the P, how many the P that this force can balance. Okay, so we can do the we can focus on the pulley A, big pulley, do the summation Fy equals to 0. So the three in this part of a small middle size pulley. Okay, so the 3P minus this force is equal to 0. So we can find the P is equal to 200 Newton. So what's the answer here? And we also can use the pulley B, do the summation Fy equals to 0. So I think it's very easy. We can get the T minus the 2P equal to 0. So it's T equal to 400 Newton. Then use the same concept, focus on the pulley C. So do the summation Fy equal to 0, use the R minus the 2P and minus the T equal to 0. Then we know the T answer and the P answer, so put these two answers into this equation, then we can get the R equal to 800 Newton. The next example, a 500 kilogram elevator car in this figure is being hoisted by motor A, using the pulley system show like this part. And if the car is traveling with the constant speed, determine the force developed in the two cables, neglect the mass of the cable and the pulleys. Okay, why this example set the car is traveling with the constant speed? Because if you have the different speed, we can get the acceleration. Then if you have the acceleration, the mean is okay. We will get other force because the F equal to mass times the acceleration. Okay, so we need to assume this speed is constant. Then we can calculate static part. So I think we will free body diagram first. So we have the one member here, and we have the these two pulley. Then because we want to determine the force developed in the two cable, so we need to find the two cable at where. Okay, so first cable from A to D to C to the elevator car. Okay, and second cable from the F to E to B to C. Okay, so we want to calculate these two cable tension force, and don't forget because the first cable is same, so each part the tensile is same, tensile force is same. So when we draw the free body diagram like this, we have the elevator car weight here, and we have the normal force between the wall and the elevator car. Okay, so you can see we have a little support here, and we have the normal force, normal reaction force, and okay, on the elevator car we have the two pulley and one cable connect. So the cable connect this part and this pulley have the same cable, so the tensile force is same. And this second part, the tensile force we assume the T2. And the C part, pulley C, we have the two cable connect together. So the pulley C, we will get the two T1 here and the one T2 here. When we finish the free body diagram, then we can calculate the user equation of equilibrium. So we focus on the pulley C first, then we do the summation Fy because only y direction force. So we can do the summation Fy equals to 0 first. Then we know the T2 is equal to 2T1, 2T1. And when we focus on the elevator car, we also, because the N1 is equal to N3, N2 equal to N4, so we don't care about this part. We just use the y direction force. So we do the summation Fy equals to 0. So 3T1 plus the 2T2 minus this weight is equal to 0. Okay, then we can get this equation. Then use this relationship put into this equation. Then we can get the T1 is equal to 701 Newton. Then we can use T1 and then use this equation, this relationship to calculate the T2 is equal to the 1,401 Newton. Okay. I think just sum around. Okay, do a sum around. So the answer will be like this. Okay, next example. Determine the horizontal and the vertical component of force which the pin at point C exerts on member BC of the frame in this figure. Okay, so we have two member, and we have two supports at point A and point C. So we can draw a free body diagram first. Okay, in member AE, okay, because only two two pin. So this is the two force member. So we just put the force along the member direction, and in member BC we have one force in here, and this force is internal force with the member AB, and we have the reaction force at the point C. So this is the free body diagram. Then we have the three unknown can determine. Then we do the three equation of equilibrium. Then we focus on the BC first. So when we put the moment point at the point C, we just use this force and this force calculate the moment. Then combine these two moments is equal to 0. So we do the summation MC equal to 0. Then use this force, okay, let the point C get the moment. Use this force times the moment on, and we can get the, okay, according to the right hand row, we can get the positive moment. And this part, I think, is negative moment. Okay. So it's very easy to get the answer. AB is equal to, okay, like this value. And we can do the summation Fx equal to 0 because we have this force. So we use this force answer and this force, then we can calculate the Cx is equal to 577 Newton. Then we can do the summation Fy equal to 0. Then use this force and this force. Then we can get the force Cy answer is equal to 1000 Newton. We also have other solution, but the answer is I think the same, so you can do and check again. So if we focus on the member AB, okay, you focus on the member AB, you need okay, we can set the moment point at the point A, then do the summation MA equals to 0. So we can use this force, okay, times the this force and this force times the moment on. Then these two force let the point A, the moment is equal to 0. And we also can do the summation Fx, summation My equal to 0. Then the equation like this. So if you focus on the member AB, you cannot use the one equation of equilibrium to solve this problem. You also need to use this part. And don't forget, if you divide into this force like this and this, the internal force I think is also okay. So when we do this when we have this equation, then we focus on the member BC. We do the summation MC, summation MC equals to 0. Then we can get the Cy answer. And when we do the summation Fx, okay, because then we know the Bx is equal to Cx. Then when we do the summation Fy equals to 0, we use the Ey, Cy, and this minus 2000 Newton. Combined together is equal to 0. Then we can do some massage. We can get the answer like this. Okay, so we have so many ways to calculate, but if you can exercise this, then you can find an easy way to calculate this, solve this problem. Okay, this next example, the compound pin show in this figure is pin connect at the point B determine the components of reaction at its support and the negative its weight and the stiffness. So we have the beam, but this beam have the two member, and we have the one support at here is the fixed support, and we have the roller support at here, and we have the two force. Okay, two force. This one is uniform force, and this one is the one direction force. So we draw the free body diagram first. So we have the two member with the two free body diagram. So in member AB, we have the reaction at the support A. This is the fixed support, so we have the two reaction and one moment, couple moment here. And we have the force at here. And point B, we use a pin connect these two members. So we have the two direction force. Okay, and this is the internal force. So the member BC also have the internal force at the point B. And we have the uniform force. We can use these represent this force. And we have the roller support at here. So we have particular reaction. Okay, then we focus on the segment member BC first. Then we focus on the member BC first. We do the summation F(x) equals to 0. The B(x) is equal to 0. And we put the moment point at the point B. Then we do the summation MB equal to 0. Then we just care this force and this force. Let the moment let the point B get the moment, and these two moments combined together is equal to 0. So it's very easy to get the CY answer. Okay, then when we do the summation Fy equal to 0, because we know the CY answer using this equation, so we can calculate the By answer. Okay. So then we focus on the segment AB. This is the member AB. Because we have the By answer and the Bx answer, so just internal force. So we know that these two force answer. And when we do the summation Fx equal to 0, then we can find the Ax. And when we do the summation moment A equal to 0, just put the moment point at the point A. So we just carry this force into this moment, and combine together is equal to 0. And don't forget this force, this force can divide into the y direction and x direction. And the y direction let the point A get to the negative moment, and this direction we can get the positive. Okay. And you also can use okay, and you also can okay, and sorry, x direction force, I think facing the moment point, so only y direction force let the point A get the moment, so only three moment combined together is equal to 0. Then we can calculate because we know the By, so we can get the A answer. Okay, finally we do the summation Fy equal to 0. So the Ay and this force and the By combined together is equal to 0. So we know the By, so we can get the AY answer. So the answer like this list. Okay. The next example, the two planes in this figure are connected together by cable BA and the smooth spacer BE. Determine the reactions at the smooth support A and F, and also find the force developed in the cable and the spacers. Okay, so we have one and two member, and we have one support here, one support here. This is a smooth support, so only perpendicular reaction. And these two member, we use the one cable and one spacer connect. Okay, so when we draw the free body diagram, maybe like this. In the AD part, AD member, we have this reaction force and this force, and this maybe tensile force, and this maybe is the support force in here, and of course these two connect. Let this member and this member combine together. So this is internal force. This is internal force. So this equal to this, equal to this, equal to this. And in the member CF, we also have the force here and the reaction force here. Okay, when we finish the free body diagram, draw the free body diagram, we can choose the one to do the equation equilibrium. Then we can get, because we want to get the BC and the DE, so just choose the one and then start your calculation. Okay, so you can see so many force parallel y-axis. So we don't do the summation Fx, because the summation Fx equal to 0 and no acceleration force. So we just do the summation Fy, and the moment at any point is okay. So we just choose the moment. Okay, we just set the moment point at the point A is equal to 0. Then we can use this force, and this force, calculate the moment is equal to 0. And we can focus on this member. We also put the moment point at the point F, and use these three, calculate the moment is equal to 0. So we can use these two equations and solve those two equations to unknown. Then we can solve these two unknown, get the answer is FDE equal to 1.4 kilonewton, and FBC is equal to 1.6 kilonewton. And we also need to determine the reaction. Okay, we also need to calculate the reaction. So just use the summation Fy. We use the summation Fy, focus on the plane AE, because we know these two answers, and we want this force. So we very easy to get the NA value is equal to this. And if you focus on the plane CF, we also can very easy to get the NF. Okay. Next example, the 75 kilogram man in this figure attempt to lift the 40 kilogram uniform beam of the roller support at the point roller support at the point B. Determine the tension developed in the cable attached to the point B, and the normal reaction of the man on the pin when this is about the upper. Okay, so we can draw the free body diagram first. You can see we have the 1 and 2 and 3 objects, then combine together, and we have the one support at point A is pin, and the one support at point B is the roller, and we also have the cable support at the point F, and we only use the one cable here, and the other one is the cable connect with this pulley and this man. So we can draw the three-part the body diagram first. So in beam part, we have the one support at the point A, so we have the two direction reactions. And the point B, we have the one perpendicular reaction come from the roller support, and we also have the tensile force at this part, and this beam have the weight. So this is the weight force, and this man also have the weight, and this man stand on this beam, so this beam will get the internal force, and this man also have an internal force, and this man for this cable. Okay, so this cable we call the tension is T2. And, so first the cable we use this. The second cable we use the E to H. Okay, so first the cable, the tensile force is same, and okay, so use the E part at here. The pulley E have the T2, and the pulley E also have the 2T1 here. Okay, then when we finish this three-member free body diagram, we can do the equation of equilibrium. So first we focus on the pulley E, then we do the summation Fy equals to 0. So 2T1 equal to T2. Okay, so we can put a relationship with the T1 and T2. Okay, and we focus on the man. And we can draw we can do the summation Fy equals to 0. So the Nm plus the 2T1 and minus the main weight is equal to 0. And then we can use this member and do we put a moment point at the point A. Then we do the summation and A equals to 0. So we have a 1, 2, 3, 4. We have a 4 force. Then the point A get the moment. So we have a 1, 2, 3. Okay, then the MB will equal to 0 because you can see the main for this cable. Then the pulley system will let this part upper. So I think the support not connect with the beam when the main pulley this cable. Okay, so the MB is equal to 0. So only these three forces let the point A get the moment, and combine these three moments is equal to 0. Then we can use these three equations then get these three unknown, then the answer like this part. Okay, and we also have the solution 2. Solution 2, I think, is the previous method. Just draw the free body diagram entire members. So you can see just only external force, like support force, like the weight from the pin, from the main, and we have the this tensor force come from the pulley system. Then we can put the summation. We can put a moment point at the point A. Then we have the 1, 2, 3, 4, 5. This we can is equal to 0, so we don't care. So 1, 2, 3, 4, 5, and calculate the moment. So 1, 2, 3, 4. I think the T1 is okay, 2T2 is combined together here. So we have the 1, 2, 3, 4, 5. 5 moment that put at the moment A, and this 5 moment combined together is equal to 0. Then we can calculate the T1 first. Then use the then we can, when we get the T1, then we can solve the AX and AY. So I think the answer will get like this constant. The smooth disc shown in this figure, and is pin at point P, so this is the pin, and has a weight of 20 Newton, neglecting the weight of the other member. Determine the horizontal and the vertical components of the reaction at points B and D. Okay, so we have the 1 and 2 and 3. We have the 3 part, and then we have 2 supports. One at point A is pin, one at point C is the rectangular roller. So, entire member free body diagram like this, just in external force. This is 2 reaction force. This is the reaction force come from point C, support C. And we also have the weight on this in the pin, or this. Okay, so we can draw this free body diagram first. Then we also can draw the 3 member free body diagram. Okay, so we just add some internal force, get the internal force. So this is the internal force, this is the internal force, and this is also internal force, and this is the internal force for point E. Okay, so then we can focus on one member to do the calculation, or we also can use an entire form, entire member to calculate the answer. So we can focus on the entire form first, and do the put the moment put the moment point at the point A, then do the summation of x, do the summation fy equal to 0, then we can get this answer. I think the same concept is in the member AB and this, then we can get the answer. Okay, and okay. Usually will give us some information, the message. Okay, next Wednesday, we will review the first example and take attendance So ask your classmate come here. Obviously will come. Okay. All classmates are kindly asked to attend. And in addition, the second exam is scheduled for the May 7th. It will cover the material from the chapter 4.7, chapter 4.7 up to this day. Learn. Okay, so I think you have 3 times exam. Okay, first finish. Second will happen on May 7th. Okay, so we start the class here. Thank you, everyone.